Welcome, Engineer Balisa Lisa and classmates. Today, our group will be talking about Title 14 Aeronautics and Space, Subchapter C, Part 23 Airworthiness Standards, Normal Category Airplanes. And for today's topic, our table of contents. For the first topic, we have airworthiness standards. And for the second to the eighth or last topic, we have subpart A to G. And with that, I shall pass it to the next presenter. Airworthiness standards. Cockpit voice recorders or CVRs. Each cockpit voice recorder, there is an operating rules and it must be approved and must be installed so that it will record the following: voice communication in an airplane of a flight crew. At the same time, voice or audio signals identifying navigation or approach aids introduced into a headset or speaker. And in addition, data link equipment is installed. All data communication using an approved data message set. To add up, the preamplifiers and filters of the recorder must be so adjusted or supplemented so that the intangibility of the recorded communication is as high as practicable when recorded under flight cockpit noise condition and laid back. And this recording requirement must be met by installing a cockpit mounted area microphone located in the best position for the recording communications for the first and second pilot stations and voice communication of other crew or the flight deck. So let's move on to the next slide. And for the CVR, we have its own sources and recorded on a separate channel, of course. So for the first, second, and fourth channel, they are the same in terms of from each boom, mast, or handheld microphone, headset, or speaker. For the difference is that the first channel is used at the first pilot station, while the second channel is used at the second pilot station, and the fourth channel is used for the third and fourth crew members. And let's not forget the third channel from the cockpit mounted area microphone. In addition, practicable all sounds received by the microphone must be recorded without interruption in respective of the position of the interphone transmitter key switch. So let's move on to the next slide. So each CVR must be installed as it receives its electrical power from the bus without jeopardizing service to the essential or emergency load, remains powered for as long as possible, and it also simultaneously stop the recorder and prevent each eraser feature from functioning within 10 minutes after crash impact. There's also an aural visual means for pre-flight checking of the recorder for proper operation. Any single electrical failure external to the recorder does not disable the cockpit voice recorder and the flight data recorder that we'll be talking about later on. And it also has an independent power source. In addition, it also provides 10 plus and minus 1 minute of electrical, positive and negative actually, of 1 minute of electrical power in the event that all other power to the CVR in the event of interruption. So let's move on to the next part, is that we have the recorder container must be located and mounted to minimize the probability of rupture of the container as a result of crash impact and consequent heat damage to the recorder from fire. Each recorder must be either bright orange or bright yellow as shown from the illustration from the slide, have a reflective tape affixed to its external surface to facilitate its location underwater, and have an underwater locating device. Moving on to the flight data recorder. Uh, Same as the CVR, the FDR also has its operating rules. And for the FDR, it is supplied with airspeed, altitude, and directional data obtained from sources that meet the aircraft level system. It also does not exceed the limit of 25% of an airplane's mean aerodynamic chord or MAC. It also receives its electrical power from the bus, similar to the CVR, and it without jeopardizing service to the essential or emergency loads, similar to the CVR again. And there is an aural visual means for pre-flight checking, similar to the CVR once again. Let's move on to the next part. FDR is also another operating rules in addition. A non-ejectable record container must be located and mounted, as well as a correlation must be established within the flight recorder readings of airspeed, altitude, and heading, and corresponding readings. As the FDR container must contain either be bright orange or bright yellow, have a reflective tail affixed to external surface to facilitate its location underwater, have an underwater locating device. Any novel or unique design or operation characteristics of the aircraft shall be evaluated as these features are shown on the illustration. And let's move on to the next part. As the applicant must prepare for the continued airworthiness, as these are the instructions for continued airworthiness, in accordance with Appendix A of this part that are acceptable to the administrator, the instruction may be incomplete at a type certification if a program exists to ensure their completion prior to the delivery of the first airplane or insurance of a standard certificate of airworthiness which occurs later. And with that, I am done for my part.
Subpart A, General, Applicability and Definitions. Letter A, this part prescribes airworthiness standards for the issuance of type certificates and changes to those certificates for airplanes in the normal category. Letter B, for the purposes of this part, the following definition applies. Continued safe flight and landing, which means an airplane is capable of continued controlled flight and landing without requiring exceptional pilot skill or strength. Certification of normal category airplanes. Letter A, certification in the normal category applies to airplanes with a passenger seating configuration of 19 or less and a maximum certificated takeoff weight of 19,000 pounds or less. Letter B, airplane certification levels are Level 1, airplanes with a maximum seating configuration of 0 to 1 passenger. Level 2, 2 to 6 passengers. Level 3, 7 to 9 passengers. And level 4, 10 to 19 passengers. Letter C, airplane performance level R for low speed airplanes with a normal and maximum operating limit speed less than or equal to 250 knots calibrated airspeed and less than or equal 0.6 Mach for higher altitude. High speed for airplanes with a normal or maximum operating limit speed greater than 250 knots calibrated airspeed and greater than 0.6 Mach for higher altitude. Airplanes not certified for aerobatics may be used to perform any maneuvers incident to normal flying. Includes number 1, stalls, except whip stalls, which is a stall during a vertical climb in which the nose of the airplane whips violently forward and then downward. Number 2, lazy eggs, chandels, and steep turns in which the angle of the bank is not more than 60 degrees. Number 3, airplanes certified for aerobatics may be used to perform maneuvers without limitations other than those limitations established under the subpart G of this part, which is the flight crew interface and other information. Accepted means and compliance. Letter A, the applicant must comply with this part using a means of compliance, which may include consensus standards accepted by the administrator. Letter B, an applicant requesting acceptance of means of compliance must be provided a means of compliance to the FAA in a form of and manner acceptable to the administrator.
Subpart B is divided into two parts, performance and flight characteristics. For performance part, first is weight and center of gravity. In this case, the applicant must estimate the weight and center of gravity in relation to a safe flight while meeting all of the aircraft's condition standards. Performance data. The aircraft must meet the performance standards of this subpart, which includes standard atmospheric conditions at sea level and ambient atmospheric conditions. Stall speed. Here, the applicant must determine the minimum steady flight speed of the aircraft for each flight configuration on normal operation. Takeoff performance. The applicant must assess the airplane's takeoff performance in relation to characteristics including stall speed, minimum control speed, and climb gradients. Climb requirements, which include all engines working on an initial climb, loss of thrust on multi-engine aircraft, and a climb gradient without adding to pilot workload in a bulk landing. Climb information, discussing climb performance data such as weight, altitude, and temperature while taking into account that the operation limits from single engine to all multi-engine aircraft. Last but not the least, landing, which the applicant must identify both the standard temperature and altitude, the distance required to land and stop, as well as the approach safety protocols. Next part would be the flight characteristics. First, controllability. Here indicates that the airplane must have good in-flight control without requiring the pilot to have any extraordinary abilities. Trim. The plane must maintain trim without any additional force from the pilot, and the system must retain residual force that does not interfere with the pilot throughout the operation. Stability. This means that airplanes must have general operation stability and can't be so unstable that it increase workload or put people in danger. Stall characteristics, stall warning, and spin. Here indicates that aircraft must have controllable stall characteristics on straight and turning flights. Ground and water handling characteristics, which says that aircraft must have manageable handling characteristics on both land and water operations. Vibration, buffeting, and high-speed characteristics. This includes the features and limiting elements of vibration and buffeting of airplane's operation. And lastly, performance and flight characteristics requirement for flight in icing conditions. Here implies the applicant who requests certification for flight in icing conditions and its requirements.
The next subpart will be about structures. The structural design envelope tackles the requirements of which the applicant must show compliance in terms of the aircraft design and operational parameters which affects the factors of structural load. Next is the interaction of systems and structures. The aircrafts that are equipped with systems that modify structural performance to comply with the requirements, the influence and failure of these systems must be accounted for. In terms of structural design loads, the applicant must determine the applicable structural design loads, loads required, and the magnitude of the applicable structural design load. Now, in terms of flight load conditions, the applicant must determine the atmospheric gust, the symmetric and asymmetric maneuvers, and lastly, the symmetric thrust. As for ground and water load conditions, the applicant must determine the structural design loads resulting from taxi, takeoff, landing, and handling conditions on the applicable surface in normal and adverse attitudes and configurations. As for the component loading conditions, the applicant must determine structural loads acting on each individual engine mount, each flight control, high lift surface, system, and its support. Lastly, structural loads regarding the pressurized cabin. Now, for limit and ultimate loads, the applicant must determine the limit loads and ultimate loads, which is multiplied by a 1.5 factor of safety unless otherwise stated. Now, in terms of structural strength, the structure must support the limit loads and ultimate loads without interference with the safe operation of the aircraft with detrimental permanent deformation. Now, for structural durability, the applicant must develop and make inspections in order to avoid structural failures and fatal injuries. The implementations depend on the aircraft since there are other types of aircraft with different capabilities. Now, for aeroelasticity, the aircraft must be free from flutter, control reversal, and divergence. For design and construction principles, the applicant must design each part for the expected conditions of the aircraft. Design data must define the part, configuration, and materials used. The sustainability of each design must also be known since it is an important part of safety operations. Now for protection of structure. The applicant must protect each part of the aircraft, including the smallest part, against deterioration. Each part of the plane must have proper ventilation and drainage. Each part that requires maintenance must incorporate a means into the aircraft design to allow such actions to be accomplished. For materials and processes, the applicant must determine the durability of each material and part according to the effects of environmental conditions, together with the methods and its processes. For special factors of safety, the applicant must determine a special factor of safety for each critical design value for each part by means of using quality controls and specifications. Now, lastly, in terms of emergency conditions, the occupants must be protected against injury with the proper use of safety equipment. Taking into account all possible hazards, all equipment must work as intended, and lastly, occupant safety is a must.
For flight control systems, the applicant must design airplane flight control systems to operate properly and protect against hazards. The applicant must design trim systems, if installed, to protect against incorrect trim operations and provide a means to indicate the following: the trim control movement, the trim position, and its neutral position for lateral and directional trim, and lastly, the range for takeoff. For landing gear systems, first the design of the landing gear system must be reliable during surface operations and in the event of a system failure. Second, it must have sufficient kinetic energy absorption to account for landing or demonstrate aborted takeoff. And lastly, for systems that actuates landing gear, there is a positive means and alternative means to bring the landing gear in the landing position. For buoyancy of seaplanes and amphibians, airplanes intended for operations on water must provide an excess buoyancy of 80% and have sufficient margin to stay afloat at rest in calm water without capsizing. For means of egress and emergency exits, the plane is designed to facilitate rapid and safe evacuation and have a means of egress or exit that is easily accessible from the inside and outside. Airplanes approved for aerobatics must have means of egress during flight. For an occupant physical environment, the airplane must be designed to allow clear communication within the aircraft, to protect the passengers, pilot, and flight controls from external objects. And for level 4 airplanes, each windshield and structure in front of the pilot must withstand without penetration an impact equivalent to a 2-pound bird when the airplane's velocity is equals to its maximum approach flap speed. The airplane must also provide air at a breathable pressure in any event that may happen. If a pressurization system is installed, the airplane must be designed to protect against decompression to an unsafe level and excessive differential pressure. For fire protection, some parts of the aircraft must be self-extinguishing and flame-resistant. Thermal or acoustic materials in the fuselage, if installed, must not be a flame propagation hazard. Sources of heat within each baggage and cargo compartment that are capable of igniting adjacent objects must be shielded and insulated to prevent such ignition. Some parts of the aircraft must be visible in case of fire and easily accessible for manual extinguishing of a fire. There must be a means to extinguish any fire in the cabin such that pilots can easily access while seated and passengers as well within the passenger compartment. Each area where flammable fluids or vapors might escape must be defined and have a means to minimize the probability of fluid and vapor ignition. Lastly, combustion heater insulation must be protected from uncontained fire. For lightning protection, the airplane must be protected against catastrophic effects from lightning. Most airplanes' outer skin is made up of aluminum, which is a good conductor that allows current to flow through the skin from the point of impact to some other point without interruption or diversion to the interior of the aircraft.
As for Part 23.2400, things that need to be considered and included in the power plant installation are the necessary components for propulsion, the type certification of engine and propeller in accordance with the FAA standard, the operating conditions including the foreign object threats, the sufficient clearance of moving parts to other airplane parts and their surroundings, the hazards in operation as well as other hazards such as accumulation of fluids, vapors, or gases, the vibration and fatigue, and lastly, the components. The components must also comply with their limitations and installation instructions. For the automatic power or thrust control systems, They must be designed to avoid unsafe conditions during normal operations. Also, inadvertent system operation must be prevented, or if not, it must not result in an unsafe condition. If the system failure is extremely remote, it must provide a means for the flight crew to verify the system is in an operating condition, as well as to override the automatic function and prevent inadvertent system deactivation. For the power plant installation hazard assessment, the applicant must make sure that any hazard resulting from failure or of the power plant will not prevent continuous safe flight and landing, cause serious injury, and require immediate action by any crew member for continued operation of any remaining power plant system. As for Part 23.2415, it explains that the airplane and the power plant design must prevent any accumulation of ice or snow that adversely affects their operations. For the reversing systems, they must be designed to avoid unsafe conditions, and the airplane is capable of continued operation after single or combination of system failures and malfunctions. And for the power plant operational characteristics, this includes the power plant operation without any hazards shown during normal and emergency operation. Also, the pilot must be capable of stopping the power plant in flight and restarting it within an established operational envelope. Next, Part 23.2430 basically covers the requirements needed for the fuel system, and the requirements include the independence between multiple fuel storage and supply systems, preventing ignition of the fuel within the system by lightnings, providing the necessary fuel for the power plant and APU, as well as a means to determine the fuel's usage during operation, capable of retaining fuel under all likely operating conditions and minimizing hazards, and lastly, preventing fuel contamination. For Part 23.2435, the requirements for the induction system of the power plant and APU must supply the air required during operation, prevent hazards in the event of fire or backfire, minimize the ingestion of FOD, and provide an alternative intake for the blockage of primary intake. For the exhaust system, it must provide a means to safely discharge potential harmful material and prevent hazards from heat, corrosion, or blockage. For the fire protection of the power plant, APU or combustion heater, they must be installed in a designated fire zone. And this fire zone must provide a means like fire detection or extinguishing system in order to isolate and mitigate fire hazards to the airplane. Also, each component line, fitting, and control subject to fire conditions must be designed and located to prevent hazards resulting from fire, be fire resistant, and lastly, be fireproof or enclosed by a fireproof shield.
For Subpart F, equipments have regulations that needs to follow such as airplane level systems requirements. Whereas it is important to have day VFR, night VFR, IFR during flight operations to meet the level of safety and to perform their function during flight operations. And those mentioned such as day VFR, night VFR, and IFR must not harm the airplane or its occupants. Function and installation. It has a requirement that each equipment must function as intended. Equipment systems and installations. Every installed equipment must prohibit failure to the extent of catastrophic failure condition, hazardous failure condition, and even major failure condition. Electrical and electronic system lightning protection. In this subpart, the equipment must be designed and installed to not be affected by lightning, and the system must recover during and after it is exposed. Each electrical and electronic system must be designed to recover normal operation of that function in a timely manner after the airplane is exposed to lightning. High intensity radiated fields protection. The equipment must be designed and installed to not be affected by high intensity radiated fields, and the system must recover during and after it is exposed. Each electrical and electronic system must be designed to recover normal operation of that function in a timely manner after the airplane is exposed to high-intensity radiated fields. System power, generation, storage, and distribution. The system must be designed and installed to supply the power required for operation, ensure no single failure or malfunction, and have enough capacity if the primary source fails to supply essential loads. External and cockpit lighting. It must install lights to minimize any adverse effects during flight crew duties and also to have anti-collision lights, position lights, taxi and landing lights for night operations, and riding lights for atmospheric conditions. Safety equipment. For this part, safety equipment must be identifiable and accessible during flight operations. Flight in icing conditions. The system must provide safety during operations and provide protection from stalling when the autopilot is operating from icing conditions. Pressurized systems elements. Pressurized systems must withstand appropriate proof and burst pressures. Equipment containing high-energy rotors must be designed or installed to protect the occupants and airplane from uncontained fragments.
Let us move on to the final subpart of Part 23, Normal Category Airplanes, which is Part G, Flight Crew Interface and Other Information. In the Flight Crew Interface section, it basically states that the equipment of the pilot and its crew must be accessible and functionable at all times for the sake of safety and readiness. This includes using equipment easily during taxi, takeoff, cruise, landing, etc. In the installation and operation section, it should be of no surprise that all systems and equipment are labeled safe and must be labeled safe. If not, then defects must be reported. Next up is the instrument markings, control markings, and placard section. To sum it up, all aircrafts that need any sort of maintenance check must be labeled by a placard and marking associated by the airplane flight manual, which I will discuss later. In this next section, flight, navigation, and power plant instruments, it states that information needed for a safe flight must be fluid. In other words, quick to access to the staff with minimal to no error. Now for the last part of the last subpart, which is the airplane flight manual, which of course, as simple as it can get, must be within every respective aircraft and is approved by the FAA, which is the Federal Aviation Administration. We have reached the end of this presentation. Any questions after the end of the video will be entertained, of course, by our group. Thank you all for listening.